Hey, amazing people, what we're going to do today is we're going to look at how to find the area of a parallelogram. Now, when you've got a parallelogram, there's a little trick you need to play in order to find the area of it. Now, we're going to look at this first, but one key thing that we do need is we need to have this B, which is called the base, and we need one other key piece of information, which is we need the height, which is found there. Now, the height is perpendicular, that means at 90 degrees to the base. And we're using that here to help us find the area of this parallelogram. Now, that might seem a little weird here at first, but what we're going to do, and I've put that red line in that location for a very specific reason, is I'm going to cut off the right-hand side of this parallelogram, and then I'm going to move it to the other side. I'll show you what I mean. Okay, now with that end moved, so from here where it was, moved over to here, you can see now that we've actually created a different shape by doing that. And this is a shape we already know how to find the area of. This looks like a rectangle. And so what we're doing here by using this B, which is the base, and H for height, is we're essentially just using the same method that we use when we find the area of a rectangle. And so therefore, the formula we are using when we are finding the area of a parallelogram is going to be equal to B times H. And so those are the two pieces of information that we need to find the area. Now, in this first example here, we've got a parallelogram, and we can see that it's got a base height to start off with, which is 6 millimeters. They've also written it for the top as well. But then we also have the height, which is 8 millimeters. So using this information, we can substitute this into the formula in order to work it out. So using the formula area is equal to base times height, what we're going to do is we're going to have 6 times 8. That's how we're going to calculate the area of this. And 6 times 8 is equal to 48. That's going to be millimeters squared. In this next example, we've got another parallelogram, but this one looks a little bit different because of how it's being positioned on the page. But we still use the same technique here. Now, first of all, it's about identifying what the base is and then also the height. Now, first of all, the base in this is going to be 7.2. So that's running from here up the top down to this side here. Now, in addition to this, we need the height, and we can see that we do have a right angle symbol here indicating that we do have height, or face being at a right angle. And so the height is going to be this here, which is 3.5 meters. So now, in order to work out the area, it's just a matter of putting these into the formula. So I'm going to replace the B from the formula with 7.2. I'm also going to replace the H in the formula with 3.5. And from here, it's a matter of putting it into your calculator to get the answer, which is 25.2, and this will be meters squared in this case. Now, in this last example here, we've got a parallelogram, but you can see that we've got 3 different numbers here. Now, part of the reason you might sometimes come across this is it's a little bit of a trick. So it's important to be able to identify the side that you need. Now, in the first instance, because our formula is A equals base times height, we only need 2 of these. So one of these we don't need. Now, in this case here, the base is going to be the 9 centimeters, which is here down the bottom. Now, the next one is to work out the height. And there are 2 numbers here which could represent either of these. Now, in this case here, what we need is we need this 3.6 centimeters here. What they're trying to do with the 5.1 centimeters is they're giving you actually the length of this side over here. They're not giving you the height. And so therefore this number here is designed to trick you. You don't actually need it. So we can cross it out and forget about it. We don't actually need that number. It's fair to trick us. So from this, if we work out the area, we're going to have our base of 9 times 3.6. And when we type this into a calculator, what we then get is we get 32.4, and that's going to be centimeters squared in this case.